So today we're going to talk about the law of cosines, and what we're going to use this for is to solve for side lengths and angle measures of triangles that are not necessarily right triangles. Now, you'd say, okay, well, why a new formula? The law of sines was working really well for us. The law of sines doesn't work well for every case. And as an example, what if you had a triangle and you were given, as your three pieces of information, the measure of angle A, and you were given side B and side C. And if you tried to use the law of sines, you would have sine of A. So you would have sine of A, and that would be given to you over A. And then you would have sine of B over B, which was given to you. And you would have sine of C over C, which was given to you. And do you see how you don't have anything complete here? You don't have a whole one complete. You cannot solve this kind of a triangle with the law of sines. This is not a thing. And if it's not a right triangle, you can't use the right triangle trigonometry either. So in this particular instance, we need something else, and that something else is the law of cosines. So that's what we're going to be learning about today. Now, the law of cosines, just like the law of sines, there are three different laws, technically. I'll give you the main one first. So a squared equals b squared plus c squared minus 2bc cosine a. This is not as bad to remember as you may think. All right. The a squared is here, right? The only place a appears on the other side is cosine a. Everything else is b's and c's. So in the next one, b is what's over here on the left, b squared. So these are a's and c's and a and c, and the only place a b is over here at cosine b. Okay, so as long as you keep the pattern straight, you can write it any of the three ways you want. Just keep in mind, whatever is squared over here on the left by itself is what you have the cosine of on the right. And every time you do this, what it is two sides and the angle that's right between them. There is no ambiguous case to this. So no ambiguous case to worry about. Now, one of the things I wanted to show you, and this is going to be a challenge for me, so we're going to see if I can make it my way all the way through this, is I'm going to show you where this thing comes from, because similarly to the quadratic formula, it doesn't come from nowhere. So I have this triangle here, and it has angles A, B, and C, and sides A, B, and this big one here is C. Now, what I've done to enhance my drawing here is drawn the vertical height h here. And I've called this little section here x. This little section is the total minus what's over here, so it is c minus x. Now, would you agree this does give me two right triangles? And if I have right triangles, I can use the Pythagorean theorem. A squared plus b squared equals c squared. So I can do that on the individual parts. So over here on the little triangle, your hypotenuse is b, right? So I could say b squared equals x squared plus h squared, okay? Because x and h are my two legs. So far, so good? Let's see the next part. We're going to do cosine of A. And cosine of A is the adjacent over the hypotenuse. So cosine of A equals x over b. That's our next factual piece of information that we're going to use. Now we're going to go over to this right triangle, and we're going to do the Pythagorean theorem here. And would you agree, this is the hypotenuse, so I have a squared equals h squared plus c minus x squared. So far, so good? Okay, so this is going to be a squared equals h squared plus c minus x squared. And I'm going to need to FOIL that out. So I have a squared equals h squared plus c squared minus 2cx plus x squared. So far, so good? And let's do this. I have x squared and h squared right here, right? Do you see how I have h squared plus x squared? That equals b squared, right? So instead of, let's write it in the color, instead of this and this, I'm going to have a squared equals b squared plus c squared minus 2cx. Now the last thing I need to do is get rid of x. So we're going to go back up here to this guy right here, cosine A equals x over b, multiply by b on both sides, and this will give us x equals b cosine A. Fair enough? Okay, that's what x is. We're going to put it in place of x. So I'm going to have a squared equals b squared plus c squared minus 2cb cosine of A. And the only thing I'm going to do at this point is put c and b in the right order. And this is going to give me my first law of cosines. So b squared plus c squared minus 2bc cosine A. And just as we talked about when we talked about the pattern here, the a squared is by itself. Cosine of A is the only representation of A on the right-hand side. Okay, sound good? Okay, so far so good. That's where it comes from. Now, let's use it. Using it is a little bit easier. Are going to want to have a calculator, though. All right, so I've got this lovely triangle here, and like I was explaining a minute ago, the kind that this is really useful for is when you have two sides and the angle that you have is the angle in between them. So it says sailboat race committee wants to lay out a triangular course with a 40-degree angle between two sides that measure 3.5 miles and 2.5 miles. What will be the approximate length of the third side? So I need to know A. So I'm going to use the formula a squared equals b squared plus c squared minus 2bc cosine A. All right, and all I'm going to do is plug all this in. We're going to plop it all in our calculator. So b squared is 2.5 squared. C squared is 3.5 squared minus 2. B is 2.5. C is 3.5. And then we have cosine of 40 degrees. Looks like a lot. We're going to put this in our calculator. I'm going to have to cover up part of this in order to do it. All right, so 2.5 squared plus 3.5 squared minus 2 times 2.5 times 3.5. You can put the parentheses in there as an alternative, and then times cosine 40 degrees. Make sure you're in degrees, not radians, when you do this. So here is everything that I need to have in there, and I'm going to click enter, and I've got 5.09. All right, so we're not done though, because that's what a squared equals. So a squared equals 5.09 0.09 approximately. I need the square root of that, right? Okay, so I'm going to use my square root key, bring up my answer key, and I'm going to have 2.26. So A equals 2.26 miles. All right? So it's really, it's kind of a long formula, but it really isn't that bad to use. All right? And you're going to use, anytime you're finding a side length, you're going to use whichever version out of the three that has the missing one on the left. If C is what I needed, I wouldn't use this formula with C squared right here. I would go up here and use the C squared formula. All right? Okay, let's find an angle measure. This is going to be a little bit more challenging. So what is the measure of angle C in the triangle at the right? So first of all, notice that we don't have our sides labeled A, B, and C. So across from angle A, this is A. Across from angle C, this is C. Across from angle B, this is B. All right? And what we need is we're going to need the measure of angle C right here, which means we need the one that starts with C squared. All right? Because that's the one that's going to have cosine C in it. So this is A squared plus B squared minus 2AB cosine C. All right, and that's what we're not going to know. So here's what we're going to do. We're going to fill in everything else. So C squared is 12 squared equals 5 squared plus 8 squared minus 2 times 5 times 8 cosine C. So I have 144. This is 25 and 64, which is 89. So 89 minus 80 cosine C. Subtract 89 from both sides. And I get 55. And divide both sides by negative 80. And I get negative 0.6875. Equals cosine C. So therefore C equals, whoops, not inverse sine, inverse cosine, negative 0.6875. Inverse cosine. I'm going to bring up my answer. And I get 133.4 degrees. Makes sense? A little bit more challenging than finding a side length. The side lengths are definitely easier, but this is still manageable. It's just using some algebra skills here. All right, let's go down here to the next example, and let's see what we've got. So we've got, let's put this is side C, this is A, this over here is B. So everything is labeled. And we have angle A, we need angle B. In order to find angle B, I need to know side length A. because remember, it's two sides and the angle between them. So this is between A and C, so I need to know A. So first thing I got to do in order to do this is find A. So this is a two-step process. So I'm going to use A squared equals B squared plus C squared minus 2BC cosine A. So A squared equals 6.2 squared plus 7.8 squared minus 2 times 6.2 times 7.8 cosine 45 degrees. So let's put that in our calculator and figure out what that is. So 6.2 squared plus 7.8 squared minus 2 times 6.2 times 7.8 cosine 45 degrees equals 30.888. So I've got A squared equals 30.888, which means I need to take the square root of that. I'm going to bring up my answer key, and I get, let's see, let's do the nearest tenth because our other ones are to tenths, so how's about 5.6? All right, so A now is 5.6 in our diagram. So the next thing is we need angle B, right? Which means we are going to use the law of cosines that starts with B squared. So B squared equals A squared plus C squared minus 2AC cosine B. So let's start plugging things in. So this is 6.2 squared equals 5.6 squared plus 7.8 squared minus 2 times 5.6 times 7.8 cosine B. All right, let's do some calculations. So 6.2 squared, this is 38.44. 5.6 squared plus 7.8 squared is 92.2. I put all this together. Minus 2 times 5.6. Whoops, that's not right. Times 7.8 gives us 87.36 cosine B. All right, subtract 92.2 from both sides. And I've got negative 53.76 equals negative 87.36 cosine B. Divide both sides by negative 87.36. And I've got 0.6154 equals cosine B, which means B equals inverse cosine 0.6154. So use inverse cosine, bring up the answer, and I get 52 degrees. So measure of angle B equals 52 degrees.